Right, is everyone able to hear me? Fine? Perfect. So I'll introduce my talk a bit later, but I just wanted to share some thoughts that are going on in my mind right now ever since I landed just yesterday. So in fact, like I lost the first day of the conference because my flight got delayed by 24 hours. But I just wanted to share some thoughts that are going on in my mind. So, and bear with me. So you know that fortunately or unfortunately, and I'm lucky that my talk landed in between two very heavyweights in the JavaScript and in the React community. So David was before me, and Kyle is going to be speaking after me. So even if you don't like my talk today, it will overall you'll enjoy because there are two people. But of course, what that leads to is having a very heavy heart because you are scared speaking in front of such an amazing audience so far, but also speaking between two very nice speakers. So I hope that I'm able to justify my coming from India. All right. Now, another context is that yesterday, the moment I landed, I just went out for a speaker's dinner, and after our dinner, we just went out for a few drinks. And I found this really unique thing that in some of the shops, which are kind of Mexican, they had these like really nice, scary clothed skeletons and these masks with people who probably you might have actually seen them if you have been to Alicante or some of the other places. And I decided that it would be fun to make something very funny. Also because we are very near to Halloween and to Dia de Muertos, which is celebrated in Mexico. So I decided to create a small demonstration for all of you. And it's over here. Let me go ahead. So this is me. I'll have to probably go back. So you can probably see that I have the React Alicante logo in front of me, and I have the skeleton. And it works pretty well. I can do a dab, right? And so the last talk that was given by David was all about AI, right? And in fact, like this is AI, but this is running completely in your browser. It is, you're not using any OpenAI keys, you're not sending any data to your server, but everything is running inside of your browser, inside of a React application with Vite. So this is a classical example of what my talk is going to be focusing today. And now I think I'll probably take the stage to officially introduce my talk to all of you, which is building machine learning models on the edge with the help of React. That means how you can leverage popular open source tools, including TensorFlow.js, MediaPipe, and leverage those to be able to build safe, secure, efficient, latency-free machine learning applications with JavaScript or with React. And very quick introduction, I'm SHIVAY, I'm from India, and I'm a TensorFlow.js working group and SIG lead from India, and also a TensorFlow user group lead from India, and I'm a developer relations engineer at Millisearch. It's an open source search engine, and very recently we actually integrated AI capability with LangChain so that you can get some product recommendations as well with related searches. But without wasting any further time, I'll also probably just take 1 minute of your time to quickly just scan this QR code and get to know that as a React developer over here, have you ever interacted or worked with AI or machine learning before? And probably this is a word cloud, right? So you can also share that if you have, then how did you do it? Did you use a library like TensorFlow.js, or did you integrate a Python-based backend with Flask, or you have not actually interacted as a front-end developer with machine learning at all? Okay, so we see Tejas, yes, Tejas is the goat. Unfortunately, he couldn't be here with us today. So some people are saying TensorFlow, not with front-end, Codepilot. Okay, people are hungry. I'll make sure to finish off my presentation in time. But what we see is that, okay, some people are using chatbots, some people are using OpenAI, some people are using with Python. But I think so there's a huge group of people who have never worked with it, who have worked with Python. But thanks for sharing. This kind of gives me a lot more perspective into understanding today's audience. So yeah, that's what we'll be learning today. So hopefully by the end of today's session, all of these answers which are either nope can actually turn into yes. I think that will be the biggest takeaway for me coming all the way from India to Spain. All right. So you know that deep learning is the craze everywhere. We see it with OpenAI, we see it with tools like Midjourney. Now, of course, the biggest question as a React or a JavaScript developer is that hey, do I need to learn mathematics or do I need to learn Python-based stacks in order to be able to integrate these machine learning models? Because that's the number one thing that will come to you. And that actually came to me when I started my machine learning journey back in 2019. And at that time, I was like a lot of people using things like Django or Flask with the machine learning server, and then I had to have a separate Node.js server with my MERN stack application. That made it a bit more complicated to learn an additional tech stack, but the answer is that no, you don't require to learn additional tech stacks thanks to a lot of different tools and open source libraries that I'll be discovering today. So of course, another very popular thing is that JavaScript is de facto the most popular the most popular language out there, and that's also because of the fact that you can run JavaScript on multiple devices. So similarly, you can technically run React on multiple sets of devices. So it runs very nicely in the browser. You can run it on mobile applications with React Native. You can build React-specific Electron-based desktop applications. And in fact, you can also essentially run React applications on your IoT-based devices such as Raspberry Pi, or even, for that matter, some of the other edge devices. So, and if you also kind of look at the top 50 GenAI web products that existed in the market, a lot of them are using the OpenAI applications, right? Because as David kind of showed in his presentation, how easy is it to actually integrate OpenAI APIs? You just make a simple HTTP request to the OpenAI server, and you're able to get a response, and you can include that in your application. So of course, for that, you have external libraries for JavaScript with the help of Replicate or OpenAI JS SDK that allow you to do that very easily. But of course, outside of those, that if you're kind of a security person and you don't want your data to be sent to an OpenAI server, can you actually handle that on the front end itself without actually needing a dedicated server or having to send your data to some other place like OpenAI if you are working with very business critical and privacy driven data? So the answer is yes. And that's thanks to a lot of different open source libraries that exist today in JavaScript, including Onyx, TensorFlow.js, MediaPipe, Transformers.js, and I'll be showing you some demonstrations today so that you can understand how we actually incorporate some of these machine learning libraries. But I think that the most important one out of all of these, which I'd like to focus on, is TensorFlow.js. Now, in terms of the growth of the TensorFlow.js project, you can see that over the past 5 years, it has grown tremendously. And in fact, we'll be sort of also uncovering that how a lot of startups and companies as big as Adobe and LinkedIn are actually using some of these libraries to optimize machine learning capability in web applications. And just to kind of introduce for those folks who might not know, so TensorFlow.js is an open source machine learning library that is launched by Google as part of the entire TensorFlow organization, and it is launched in 2018. And since then, as you see, that there have been more than 500,000 downloads on NPM. And again, the biggest use case for TensorFlow.js is that it allows you to run machine learning directly in your web browser. So that means that you don't need a dedicated server, right? That means since you don't need a dedicated server, you're getting lower latency because all of your calls are being made directly in your local machine. You have higher privacy because you're not sending your data anywhere to a cloud or to, let's say, OpenAI. And of course, since you don't require a server, there is less cost of actually maintaining and running this. But of course, you can also run this on a dedicated Node.js server as well. So it will work pretty well outside the box with Node.js. In fact, you get some additional benefits of the just-in-time compilation of Node.js to make running, let's say, very large models easier on your Node.js-based backend application. And primarily, there are 3 different ways in which you will essentially interact with TensorFlow.js. So either you can use some pre-existing models. So what does this mean? That you have the model already trained for you. You don't need to know anything about how that model was trained or any mathematics happening behind the scenes. And you just use some out-of-the-box functions like .predict, that where you'll send an input and you'll get a response. Or you can use the retraining of the existing model with a terminology in machine learning called as transfer learning, which allows you to take an existing model and retrain it over your own existing data to probably make it more optimized for your own data set. And if you are in machine learning aficionado, you can, of course, write these models right from JavaScript itself. You don't need to use Python, which is generally the most popular machine learning Python like language that you typically use for writing machine learning models. So you can do everything within your entire JavaScript ecosystem. And we'll be taking a specific look at the pre-built models because these are some of the easiest to get started with. And there are like bunch of different types of models. I'll not waste a lot of time talking about these, but you can just visit tensorflow.org/js/models. And there are a bunch of different ones if you want to do like text analysis or if you want to do something with your human body like I did. So the one that I specifically used was post estimation, right? So what you saw was that I essentially used post estimation that kind of took a look at all of my different joints in my body, and then I overlaid them with these skeleton-based images, and then by using some simple mathematics, as I moved my hands, it is able to actually track that and overlay that skeleton body on my body. So that is using one of the post-estimation-based pre-built models. And in total, it took me more like less than 2 hours to actually complete that application. In fact, like I built it yesterday night before coming to the conference. And there are some like very popular examples of this. For example, face mesh is one of those pre-existing models that are actually used by L'Oreal for being able to do AR-based lipstick tryout, right? And there are some other very popular models like CocoSSD, which is a very famous object detection or object recognition model that can detect specific objects inside of an image. And here's like one example. I hope everyone is able to read it. Perfect. So here's like one example of like, let's say, building a simple image classification component in React. So of course you would import React and you will import a couple of different libraries which are your TensorFlow libraries. So the first thing that you see in line number 2 is the TensorFlow core library itself, and then the other example is where we are using one of the models from TensorFlow. So in this case we are using the AutoML, and in this what we are doing is that we are waiting for the model to load first in your browser. And then we are just simply passing an image to it and using the tf.automl.load image classification, which basically takes your input image, it renders some outputs for you in terms of like what it is able to predict from the image, and it will go ahead and classify the image. In this case, we are passing an image of a flower, so it will give you a response related to that. Now, we'll also take an example of the CocoSSD model, right? So just some simple code snippets to help you kind of get started with how would you integrate a simple JavaScript-based or machine learning-capable React application. So the first is that we'll start with creating a new React app. We'll just call it, let's say, TFJS React Alicante. And we will install all those same libraries. The only difference that you'll see is that instead of the AutoML, this time we are using the CocoSSD, which is one of, again, as mentioned, one of the most popular machine learning libraries or machine learning models that are available. Then we'll just import them in our app.js, and we'll wait for the model to load. So again, this is something that is very typical because the models are not directly just there inside of your application. You have to wait for them to load in your browser, and then using the browser memory, right? That is how we are able to use these machine learning model inference to be able to get the results. So we'll wait for the model to load. Now, this is the UI part where we are essentially having three very simple components. We are having a button that will actually start to detect whatever is there inside of our image. We are having our webcam. So from our webcam, we will basically fetch the frames that we are getting from our webcam. Now we'll pass that one of those images that we get from our webcam in our function, right? Which I'll just quickly show you. And we'll render the actual result on the canvas. So on the canvas, what we are basically rendering is essentially this bounding box that you see with like whatever it has detected. So in this case, the class, for example, over here in this dog image, it renders that it is a dog with 98% confidence that it is a dog. So we'll basically do that in the UI. And here is like the prediction function where we are simply just taking our canvas image. And what you'll see over here is we are running this if predictions, right? So you see over here model.detect document. So this model.detect is the CocoSSD based function where you're passing the image and it is detecting what is there inside of the image. So whatever specific image classes that it predicts, for example, if I sent an image of a dog, it will be able to predict where exactly is the dog located inside of my entire frame, give you the coordinates of those frames, and then we are just creating a bounding box. So rest of the entire code, right, that you see over here is basically running with all of your code that is essentially just fetching the coordinates that you get from your predictions and creating a rectangle like the bounding box. So the actual machine learning code, if you see, is not more than 5 to 6 lines of code. And you don't need to know anything that goes on behind the scenes with this COCO SSD model. Everything is happening for you. And if you want to, let's say, use some, of course, the examples that I showed was typical JavaScript-based NPM modules that you could integrate inside of your custom React component. But if you wanted to use like dedicated React components that have some of these models built in, so this project by Infinite Red AI Labs, this is an open source project that underneath it uses the TensorFlow.js library, but it gives you ready to use React components, for example, for image classification and some of the models that I've covered so far. And you can also use this directly as well. And just to kind of show you some of the examples, right, of real-world companies actually using some of these libraries. So here is Include Health, which is a startup for healthcare, which uses the PoseNet library to be able to do things like count the number of reps you're doing. And all of this, again, happens inside of your browser. There's no information going to Include Health. Everything stays locally in your machine. Similarly, Adobe recently, I think it was yesterday that they actually launched Photoshop for web. Some of you might have probably read that tweet. And in fact, they are also using TensorFlow.js to be able to do certain object detection in the browser itself. And LinkedIn also uses WebML, TensorFlow.js to be able to optimize certain images that you see in the entire LinkedIn feed. So it just goes on to show that these libraries are just not for like gimmick, but actual usage is being used by both large companies and by startups alike. So of course, we kind of covered this earlier, but I'll just kind of repeat some of the biggest benefits. You're getting privacy by being able to run these machine learning models on the browser with your React applications or JavaScript applications. And I think I'll not like take a lot of time because we have already kind of covered some of these, but it's still like very important to consider because you're saving so much amount of cost by not having a dedicated server. And if you're interested to kind of learn more about the core TensorFlow.js library itself, there's a free online course that is available on the YouTube playlist. So it's a YouTube playlist. So if you're interested to kind of learn more, you can check out this particular course. But moving to the second part of the talk, right? So of course, the first kind of 20 minutes were all focused about this TensorFlow.js, but there are a plethora of different other options for you to choose from. So some of these include libraries like Onyx, LangChain, Transformers.js. Of course, David kind of covered very deeply into how you can leverage OpenAI, how you can leverage the entire premise of large language models to be able to build things like chatbots or to be able to get things like text summarization. All of this can be handled very easily with the help of things like LangChain, right? So in fact, like all of these different core libraries like LangChain, and of course we covered OpenAI, they do have JavaScript-based SDKs that allow you to very easily interface your OpenAI keys and your LLMs, which is the large language models, directly inside of your JavaScript or React applications. So one such project is the AI.jsx. I'll recommend you to check this out if you are willing to kind of get deeper into LangChain and large language models. This is one of the, I would say one of the most optimized libraries that you can actually use in order to integrate LangChain and large language support for your React applications. Here, for example, like one example where you just input this and you get like this chat completion. So it just simply gives you a chat completion component and you're able to do that. So you don't have to write that entire OpenAI code where you wait for the streaming to happen. And I'll be actually showing you one such example, but this is like a really good project that is growing very popular these days. If you want like some interfacing built on top of the regular OpenAI embeddings that you actually get. And of course, if you want to integrate OpenAI with Next.js, I think probably most of you must be knowing Nutlope on Twitter. Hassan, he has been creating some extremely viral AI applications. In fact, like he's releasing like one application every week or so. And that just goes on to show that how easy today, it is to integrate some of these applications like OpenAI. Of course, I mean, this is like one such example. I'll not probably take a lot of time because a lot of this was already covered by David in his talk, but we are simply just using OpenAI with Vercel. And I think like what I like to point out is that Next.js with OpenAI is especially really good. Like that combination it works out very well because you leverage the use of Vercel edge functions, and you're able to very quickly get your stream results that you're able to get as a response from OpenAI. And it works out pretty well out of the box with OpenAI and with Next.js. So that is why I just wanted to point out that even without like React, like it'll work well with React as well because you get the JS SDK, but I think especially with Next.js with the Vercel edge functions, it works seamlessly, it's very fluid, and you get very quick responses. So definitely check like this particular playlist as well if you're kind of curious to know how he was able to integrate. There's a YouTube video that he has also created regarding the same. But another one example that I wanted to point out was, and this is something that we as web developers probably, personally on a personal level, I have not seen a lot of people leverage, is the use of web worker threads. How many of you have used web worker threads in your typical use case? Just a quick show of hands. Because I see very few people. But I think web workers are such an underappreciated or underutilized feature of JavaScript that JavaScript and the entire web ecosystem has to offer to us that I just wanted to kind of point out today with the help of an example. So essentially, just think of the web workers as this way that you're having your main JavaScript thread free from any AI capable or AI enabled inferencing. So we know that machine learning itself is very compute intensive, right? So how can we make it a bit more easier so that we can offload the entire inferencing part and let the web workers handle that? So that is what the example that I'm going to be showing you right now is essentially doing the same. For that, what I'll do is I will go ahead and kill off my skeleton application example, and I'll run my example for web workers. So let's go to localhost 3000 again. And this time what I'm doing is, I'm using again a library called transformers.js, which is again an open source machine learning library that allows you to do things like text summarization, sentiment analysis. So this particular example that I've built over here is actually doing sentiment analysis, right? So let's say, I'll start with this thing. I'm extremely scared because I'm giving a talk at React Alicante. And of course, it is able to detect my sentiment, which is negative because I am extremely, I'm extremely scared right now. And also because my talk is in between David and Kyle. In between David and Kyle. So my sentiment is negative, right? But now what I'll probably say is, but I am also super happy that I got an opportunity to present at React Alicante. And overall, now the label is positive, and actually, I'm just 10 minutes left into my presentation, and I feel a lot easier and at peace, and it's really good to see that people are actually responding well, even after 25 minutes. So I think I'm doing a fair job till now. Perfect, thank you. So of course, again, this sentiment analysis that you see is running completely inside of my browser. I'm not using an OpenAI application or any other tooling which is powering this. So everything is happening inside of my browser itself. Now let's take a quick look at how all of this is happening, right? And I promise I'll not take a lot of time. I'm left with just 9 minutes. So this is my index.tsx file. I'm simply just having some UI elements from Next.js. And I'm having a few states that kind of take care of, whenever as I'm writing my text inside of my text box, it is continuously actually sending that entire text message in the text box to my function, right? To the function that is interpreting the sentiment analysis that I'm actually doing, right? So all of these states that I'm managing. Now, of course, one thing that you'll see is that I'm having this use effect. So this use effect that I'm using is actually connecting with my web worker, right? And I'll quickly also show you that what my web worker is doing, because that is like the star of the entire show. So in this AI.worker.ts, essentially what the web worker is doing, that I have essentially offloaded my entire AI inferencing. So that means loading my AI model. Then whenever I get any input stream of the text that I'm sending in my text box, and then when this model is inferencing that entire text, all of this is actually offloaded to my web worker. So my main JavaScript thread is free from doing any of the heavy lifting, and everything is being handled on the side with the help of my web worker. So by using useEffect, I'm just essentially communicating with my web worker whenever I'm having the text message, and I'm having a progress bar as well, where I'm using rendering, like conditional rendering, to basically share the response. What you'll see over here is like I have proper progress bar, as well as the AI model is taking all of the text that I'm getting on the fly, and it is rendering the result, right? So all of the actual AI-enabled inferencing is being offloaded to my web worker. So that is why all of the code that you'll see in my ai.webworker.ts is I have an event listener where whenever a new text is being sent out to it, it will use that, it will generate the response from the model. In this case, it will be the sentiment, and it will send that back to my, using the useEffect, which I'll then render on my UI. So that is why what you're seeing over here is that with the useEffect, that's essentially what it's doing. And then I have a function on text change, where whenever I'm changing anything on the fly, that's being sent to my web worker. And using a simple UI element, I'm just rendering that result, which you see as a JSON response that is coming from my actual machine learning model, right? So again, fairly simple, right? We didn't have to understand any AI capability. I was using this particular model, which is the Distilbert model that is used for sentiment analysis, and I didn't have to understand any AI that's happening behind this, this natural language processing. I just simply used the classifier function to be able to get whether I had a positive sentiment or a negative sentiment, right? So again, this kind of shows you that as a React developer, you no longer have to be scared to integrate AI capability, right? Whether you use some of the off-the-shelf AI models that are directly available to you, or like let's say if you want to just use simple APIs and you make calls to OpenAI or to replicate, right? So that's the main agenda that I kind of wanted to share. So the next slide, I kind of just talks more about how I'm using it. I've kind of already covered that. So of course, here are some resources if you feel like if you want to get started with either TensorFlow.js or the models that I kind of showed to all of you, the pre-built models, and of course the actual machine learning model that's TensorFlow.js is open source for everyone, so you can check that out as well. And then I have shared links of a couple of examples where you can actually integrate LangChain inside of React, and one demonstration by Vercel itself where they are integrating LangChain. Of course, we didn't talk a lot more about LangChain today because of time constraint, but LangChain allows you to build certain integrations on top of your regular OpenAI embeddings designed for large language models. So it gives you certain functions that allow you to build a chatbot-like functionality very easily. So there are a couple of different guides that will actually help you out a lot. But with that, I'll conclude my talk, and thank you for being such an amazing audience. It's always great and a huge pleasure to be able to, speak in front of such a large and engaging audience. And I hope that, from today, we take a pledge that probably today itself, because literally the examples that I showed to all of you did not take more than 2 hours. So what I'll recommend to all of you is that probably today, or once you go back home, once you're done with the conference, of course, you have had a lot to take in today. But I would request everyone to build an AI-capable machine learning React application and then share it on Twitter. You can probably tag me if you want, if you want, but you can use the hashtag WebML. So this entire premise of JavaScript and web is very popular. It's getting huge these days. And I think I'm a huge believer of this hashtag WebML, which means web-enabled or machine learning-enabled web, right? And because we have such a huge amount of tooling available to us, that it's truly easiest in 2023, and it's going to be just becoming easier as we enter 2024 to build React-enabled, or for that matter, web-enabled machine learning capable applications. So I'll ask all of you to take a pledge and just spend some time, probably a few hours, build some React machine learning capable applications and share them on social media, so that more and more people also get inspired and less people are scared as JavaScript developers to integrate machine learning, and we make machine learning love JavaScript, which till now was by Python. So my goal is to dethrone Python and make JavaScript as the de facto language for machine learning. Thank you.